Good afternoon, everybody, and welcome to our afternoon session for the REYES program. I have the honor of introducing our next speaker, Marilek Robles. Uh, Marilek Robles is the project scientist for NASA GLOBE Clouds and an education outreach coordinator at NASA Langley Research Center with Science Systems and Applications Incorporated. She engages with students and teaches through the GLOBE, which means Global Learning and Observations to Benefit the Environment program, NASA's largest and longest lasting citizen science project about the Earth, with participants from over 120 countries around the world. Ms. Colón Robles is the recipient of the 2017 Women of Color STEM Award for Educational Leadership, Corporate Promotion of Education, for her passion to expose as many students, particularly those in underserved communities, to STEMs, science, technology, engineering, and mathematics, and has been recognized during multiple NASA Hispanic Heritage Month celebrations. Marilek received her Bachelor of Science degree in chemistry from the University of Puerto Rico, Rio Piedras, her Master of Science degree in atmospheric science from the University of Illinois, Urbana-Champaign, and she completed the Endeavor STEM Teaching Certificate Program in STEM education through the Teachers College of Columbia University. Ms. Colón Robles was born and raised in Rio Piedras, Puerto Rico. She now lives in Yorktown, Virginia, and is a wife and mother of two beautiful girls, an accomplished musician, and an avid volleyball player. Again, it's an honor for me to introduce Marilek for you for this next 2 hours.
Thank you so much, Rafael. And hello, everybody. My name is Marilek Robles. And I'm very excited to be here to talk to you about NASA GLOBE Clouds. Now, a little bit about me. Rafael did a great job with the introductions. I am the project scientist for NASA GLOBE Clouds. So GLOBE is an international program, and there's different observation types that you can do, clouds being the most common and the most popular of them. And I love clouds, so I love it all around. Like I said, I'm from San Juan, Puerto Rico. Rio Piedras is a town in San Juan, Puerto Rico. And that's where I studied. I played volleyball, I did music, so this is me with my music group. We played music that was typical from the African slaves that were in the island in the 1500s. And that's why we have the big barrels of drum and stuff. And from this type of music, which is called bomba en plena, is where salsa and merengue comes from. So we were able to travel all around the world, almost as much as I've traveled for science, but for music. And then I did my degrees in atmospheric sciences, which means that I studied the clouds in the atmosphere. So this is me in graduate school, and I actually flew inside of the airplane, and we went inside and outside of clouds and looked at what was happening inside of the clouds and what was happening outside. Because aerosols, or these particles in the air, like dust is a type of particle, smoke is a type of particle, those are needed in order to form clouds. And then once inside of clouds, when a cloud dissipates or disappears, it changes the aerosols in the atmosphere. And so we looked at that a lot during the campaign that we did. I love volleyball, and at NASA, unfortunately, we cannot be together right now because of safety, but there are multiple volleyball teams. So this is my volleyball team. This is a volleyball that I'm holding up in the picture, but it's a little bit cut off. There's also basketball teams, there's running clubs, there's gardening as well. There's different things and different ways that we at NASA Langley and other NASA centers just spend time together. So just to give you an idea, on a typical day, I would have gone to NASA Langley in Hampton, Virginia, showed my badge, went to my office, worked in the desk between 8:30 or 9 up to 5. When my little girls were younger, I would drop them off at the daycare, which was inside of NASA, and then come back to the office. And then sometimes I would go back home or stay later and then play volleyball. So this person here is the second in command right now of the center overall. His name is Dave. Here is Brian, and he is an aerospace engineer who works a lot with airplane simulators. This is Scott, and he works inside of one of the 22 different wind tunnels we have in NASA Langley. And then these two ladies are atmospheric scientists, just like me. And then he is a technician, so he fixes the wind tunnels and makes models. The people in these pictures that have the PhDs are these two ladies right here. And so you get to work and play with a lot of different people, which is really exciting. And we all come together as equals. If you heard all the different positions, it doesn't matter in the volleyball court. These are my girls right here, Elizabeth and Madison, and we've made some videos during this at-home time. So I invite you to look at them. This one is about dust, but we also talk about clouds. So I'm really excited to be here with you all and happy to answer any questions you might have. The GLOBE program, has anybody heard about the GLOBE program? You might have. It's been around for 25 years. It's been quite some time. Right now we have 123 countries part of GLOBE. And so GLOBE is sponsored by NASA and supported by NOAA, NSF, and the Department of State. And then it's implemented by UCAR. The Department of State is involved because each country signs an agreement to be part of the GLOBE program. So if you're in a country that's a GLOBE program, you are able to participate, send in your observations, and your observations are then used by other students, teachers, citizen scientists, and even researchers around the world. There's 34,000 schools participating. There's over 200,000 citizen scientists and over 400 plus publications. And these are all the countries that participate. Really, really nice program to be a part of, and you can be a part of it as well. One of the ways that you can be a part of it is through the Globe Observer app. The free Globe Observer app you can download, and it's available for iPhones and Android devices. All you look is for the app that says Globe Observer. And there's 4 types of measurements you can do. You can do clouds, which I'm going to focus on today. But you can also do land cover and take pictures of the type of soils around you and the cover. So is it grass or the trees, things like that. We're trying to monitor change. You can use your phone and move it up and down to look at tree height. So if you have a tree that you can go to safely and you can see the bottom of it and the top, you use your phone to take a picture all the way to the top of the tree, and then you walk to it, and with simple geometry, we get the height of the cloud. You can also look at where mosquitoes are laying their eggs, and you can tell us if you find mosquitoes, and then you can go a little bit deeper and identify the type of mosquito based on the pictures of the larvae. So with all of these, we love pictures, and we use those pictures and those data in different ways in research. So this is what the app looks like when you look at clouds. You can submit observations at any time. And then look at this button right here. It says check satellite flyover. So the team that I'm a part of at NASA Langley Research Center, we match each observation made through GLOBE or the Globe Observer app to satellite data. And that's really cool. So let me stop sharing here for a second so you can see me. So we match your observations to satellite data, okay? There's different types of satellites, but all you have to do is make a cloud observation. It gets to us, we look at the different satellites, and then we send you a NASA personalized email with your observations and the satellites data. Now, satellites are great, but they're not perfect, right? We both have advantages. The satellite has an advantage, and we from the ground looking up have another advantage. And that is the power of our observations. And that's why researchers are so excited when I tell them that I have such a data set comparing to satellite data. So I'm going to show you a video quick on how it'll show you how to use the app. So if you haven't, if you would like to go and try and look for the app, remember it's Globe Observer. You can also go to the Globe Observer website, which is observer.globe.gov. Now I'm going to mute it. The Globe Observer app comes in different languages, which is really, really neat. You can go in settings and change the language of the app. You go through some questions, some trainings, and then you just click on new observation. It'll read your location and the time, and then it'll ask you, do you see clouds or no clouds? It'll have pictures that'll help you out, figure out the best answer. And that's really what we want, is your best answer. It doesn't have to be perfect at all. We'll ask you for cloud cover. That'll be the first question. If you say, yes, I saw clouds. Then we'll ask you for the deepest blue you see in the sky. The color of blue will kind of tell us a little bit about the number of aerosols in the sky. Now we'll ask you for visibility. You have to look to the horizon and then tell us again how many aerosols you see or the visibility. Then the fun really starts, because then we ask you for cloud types, and we'll start with high clouds. We'll ask you how many of those high clouds you see, and then the color. Is it transparent, opaque or dark, or translucent, like very bright? Once you're done telling us the cloud types, we'll ask you the surface conditions. This is really important when we're comparing it to satellites, because the satellite's looking down. And then the fun starts, because then we ask you for pictures or photographs. So if you notice, there's a black outline, and all you have to do is put the letter of the direction you're pointing at, the cardinal direction, inside of that circle, and the picture is taken. Then you can save the data on your phone until you have Wi-Fi to submit it, or you can submit it at any time. Once you submit it, then it comes to our team, and then we match your observations to satellite data. It's really, really neat, super simple. If you use that satellite flyover time, you can send yourself reminders of when the satellite is about to come in your area. So like, I get notifications in my phone when a satellite is going to be overhead. And so as long as you make an observation about 15 minutes either before or after that time, then you get a satellite match. And so again, this is how it looks like. If you keep scrolling here on the screen, you'll see all 4 types of observations. If you click on clouds, it'll read the date and time, your location just off your phone, and then are there clouds? Is the sky cleared, or is it obscured? Obscured just means that there's something blocking the view of sky
Marilek,
clouds. Yes.
for some reason, the presentation stopped showing. I thought that this was one of those slides that you told me that you were going to be quiet, but we cannot see it. Since you start explaining the app, nothing has been showing.
Okay, let me try and reshare again.
And I think that we lost your camera too, right, Scott?
Yeah, I'm not seeing the camera or the content. I'm kind of wondering what that's all about. I think we've lost. I don't see her in the meeting anymore.
Can you hear me?
I can hear you, but I don't see I don't see you actually in the meeting anymore, like in the as a participant.
Oh.
Are you able to try to share and reshare, or unshare and then reshare?
Yeah, I think what happened is that this platform crashed, but for some reason you can still hear me. So I have no control.
Could you? I know this is kind of crazy, but could you log out and log back in?
I'm gonna try.
Marilek, do you want me to share the video in slide 5 while you're doing all that?
I'm gonna try and leave Cisco, but it's not letting me. So sure, can I just be a talking head? If you can hear me.
Yeah, we can hear you.
Yep,
And
we can hear you.
I can share the presentation. Let me go.
Okay. Just the WebEx crashed and I cannot do anything. Like everything is grayed out. I can't close it. But if you tell me, so if you go to slide 7, Rafael, I see you in the slide deck. Are you there?
That looks good. It looks like he's got the slide up.
Okay. Okay, so you can make cloud observations. It'll read your latitude location, and then you just say if you see clouds, clear sky, obscured. What I was saying with obscured is if there's something in between you and the sky. So this could be smoke plume, dust plume. For those of you in Puerto Rico, there was a giant dust plume from Africa, right? It actually made it all the way to Kansas. So no matter where you were at, you probably saw some of the dust, right? So that would be an obscuration. The sky completely white might not be. It might be just covered with clouds. So just be careful, or just try and see if there's any puffiness is my tip with that. If there isn't any puffiness, then it might be just aerosols. Now, if a building or a tree is blocking your view, you can try to move as long as it's safe and you're following your local area's suggestions because of the current times that we're living in. Can you go to the next slide, Rafael? And just let me know when you're on slide 8.
Yes, I have it.
Okay, perfect. So in this slide, I'm showing you the clouds wizard. Now, this is something brand new, and I hope you all like it. It's a kind of like yes/no questions for you to figure out what cloud type am I looking at. Cloud types are one of the most used data sets for clouds and research. So again, we want your best guess, and this should help you out. So it'll ask you Is it puffy? Is it layered? Is it wispy? And then you do yes, no. Now, if you notice, the screen or those pictures have a little hand with arrows pointing to the left and to the right. So that means if you swipe or if you move your finger, you put your finger on the screen and swipe to the side, it'll show you different pictures of the same cloud type. So that's really useful to figure out what cloud type are you using. Now, if you are a cloud expert, you can go through the other way and then just submit what you observe. Can you go to the next slide and let me know?
We are in 9.
Okay, perfect. So this is the best thing ever, is taking photographs. And the photographs are what is the other way that it gives it a huge importance. So if you notice, there's a little circle and then a letter. So it'll take pictures in each cardinal direction: north, south, east, west. Then we also ask for a picture straight up and a picture down to see the land cover. So all you have to do is put that letter in the circle and it'll automatically, woof, take the photo. Can you go to the next slide?
Done. Done.
Okay. Perfect. So this is an example that one of my friends took. So again, it'll take photographs of each cardinal direction: north, south, east, west, up and down. It's up to you how many photos you want to take, if you want to do all 6, or if you just want to do 1 or 2. The cool thing about this is you see kind of like what's happening, right? The south view looks very different from the north view. The up view, you see some of the contrails, so those straight lines of clouds, but not all of them. If you notice, I see a lot of them in the south or the S direction, and some in the west or W direction. Contrails are clouds made by airplanes, and those are another type of data set that we used a lot. Can we go to the next slide?
Done.
Awesome. So I just wanted to point out a few things. Under the cloud, the little cloud that says Globe Clouds, you'll see the number of observations you've done so far. If you click on the orange button that says Check Satellite Flyover, you'll see all the satellites that'll be over your area for the next 2 weeks. So there's Terra, Aqua, NPP, and there's also geostationary satellites. So no matter what time of the day you go out, you will probably get a match, especially to geostationary satellites. And I'll go a little bit over what that is. If you notice, it says Set Notifications. If you click on that, then that'll push notifications to your phone or tablet to let you know at what time to go out. And remember, it's 15 minutes before or after. And then if you go to the little key on the bottom, you'll see the cloud identification chart. And that's on the right of that slide. So there's a lot of resources there for you within the app. Now, can we go to the next slide?
Okay.
Okay, so again, the power of this data set is that we are giving researchers and people around the world observations from the ground up looking at clouds and satellite observations from the top looking down. So the satellite looks at the top of the clouds. People look at the bottom of the clouds. And then together, it makes a complete story. Now, sometimes when the instruments aboard the satellite are looking down and detecting clouds, it might not detect all of them, especially if there's really thick thunderstorms or something like that. It might not see the lower clouds. Similarly, when we're looking up and there's a lot of different clouds at low level or mid level, we might not see the high clouds. So again, a complete story is if we have both views together. Now, next slide.
Okay.
Okay. Now we've done a lot, some of the papers or some of the research papers we put out is using some of these observations. One of them, I hope you guys went out and saw the total solar eclipse in 2017. If you did, it's going to happen again across the North America in 2024. I'll probably be in Texas. I think that's our plan, is to be in Texas. You want to be in a place where there's not a lot of clouds. For this one in 2017, we went to South Carolina, and we were lucky that there weren't many clouds. It actually cleared up just moments before the total solar eclipse. So total solar eclipse is when the moon goes between us here on the earth and the sun. And we asked, in the app, there was an eclipse portion, and it'll come out again in 2024. And we asked people, tell us the temperature and then the clouds that you saw. Was it mostly clear? Were there no clouds? Things like that. And we took that data set and then we were able to look at how cold did it get. So if you look at the top left graph, I know that there's a lot there, but it shows you temperature. And then there's like that big dip in the middle where the arrow is pointing. That's how cold it got. So that's how cold it got in the US in the path of totality, meaning where the sun was completely covered by the moon and no clouds present. Now, if you move to the right, you're adding little by little with each graph more clouds until you go to the bottom right, that there's basically all covered with clouds. And you notice that that dip is much, much smaller. So this was really cool to be able to do with citizen science data or data taken by people that were not scientists. Can you go to the next slide?
On.
Awesome. And so what we saw is that for citizen scientists, it's really cool to use that data because you've got a lot of people. We had 22,000 observations. People can move anywhere, right? If they can. Depending on how small of an area you're looking at, it might have been not too many observations in that little area. So if we were looking for just one state, maybe there weren't enough. But once we looked at the entire country, or like East Coast versus West Coast, there was enough data there. And everybody's doing their best guess. So there's no way to figure out who did it best or less. And that's okay because the positives outweigh the negative. We also compared meteorological stations in this research paper. So looking at data set that is research grade, there weren't that many on the path of totality. You could not move them, right? They're in fixed positions, but you knew how to use that data. It's not that the data is best, it's just that we know how to work the data, and we know how to we know what are the limitations of the data. So we know what we need to do to correct it. And then there's continuous data because these are machines. If you go to the next slide, I'm talking about, in that slide, we've done data challenges. And right now, my friends, we are in a data challenge period. It started last week, and you can make cloud observations and be part of the data challenge. So we did a 2018 Spring Cloud Challenge. In 2019, we did a Fall Cloud Challenge. And now in 2020, we're doing a community challenge during the summer months. What we want to do is get cloud observations during each season. So we did spring, we did fall, and it doesn't matter if the southern hemisphere is not in spring or fall as the northern hemisphere is. We just want data all around the world. And right now we have a paper that came out in February about this data set, which is really, really cool. And you can go to, again, observer.globe.gov website. You can learn more about the app, discover the current challenge, but also go to the publications, and there's some papers there. If you go to the next slide, you'll see our current challenge. So it's the 2020 Community Cloud Challenge. Science is better together. It started last week in July 15th, and it'll go until August 15th. And there's 3 ways for you to participate, because we want to make sure that you're always safe. Safety is #1 at NASA. So that includes you. 3 ways to participate. 1 is at-home activities. So things you can do at home to learn more about clouds, become a cloud expert. We have weekly videos from NASA scientists and educators to learn more about clouds and the interests of NASA and clouds and citizen science. And then 3rd, as long as you're safe, you can take cloud observations with the Globe Observer app or through the Globe program. Can you go to the next slide? Now, ways to participate at home activities. We've made this activity tracker, and it's in Spanish as well. It's in English and in Spanish. If you go to observer.globe.gov, you'll click on the challenge. And I think we've already put the Spanish page up there. If not, go to the blog post, and it'll take you to my blog post on the Globe program, and I've made it in Spanish. And there's 4 ways to do this activity tracker, or 4 topics. You can learn about clouds, create with clouds, engage with the community, and observe clouds. And if you look at the activity tracker, those little clouds, there's clouds with words in them. Those are different activities you can do. And the idea is that once you do one of them, let's say learn more about cloud opacity, Facebook watch, that means that there's a video that's going to come out in this time period where you can learn more about opacity. You can gray out that cloud and then keep track of how many activities have you done and per topic, and then see what is your total cloud cover. Did you gray out all of them or just some of them? No matter how you participate, you can be part of this program. You don't have to do X amount or X amount of observations. Just do some and then share with us through social media and hashtag cloud challenge or tag Globe program, and then we may showcase what you've been doing. If you click on the next slide, it'll talk about weekly videos. So this is another way for you to participate. We actually started 2 weeks ago with the weekly videos to announce the challenge, and you'll notice me in week 1 video, and it's about satellite matching. And so you can go and watch this. All the videos will be premiering on Thursdays at noon Eastern time on NASA Earth Facebook account. So this Thursday at noon, Mr. Chris Betka, who's a research scientist at NASA Langley, will talk about how he uses geostationary data for clouds in his research. So each video will feature a science topic and an activity. So can you click on the next slide? Slide 19 now. You'll see all the different topics. So week 2, last week was citizen science. This week will be clouds and weather from 22,000 miles away. That's geostationary data. Next week is clouds and earth science, or Earth's climate. The week after that will be aerosols and air quality. And then the last week, to round up the challenge, we're going to talk about a little bit more about what we found by using your observations and research. If you click on slide 20, next slide, it'll be all the at-home videos, at-home activity videos. So follow different NASA educators and Globe educators on different things you can do at home with your family or on your own to practice more to learning about clouds. And then slide 21 is taking cloud observations. Now for this challenge, this is optional because we want you safe, always safe. Now, if it's safe and you're following the guidelines, your local guidelines, please take as many observations as you can. Take photographs, tell us the cloud types that you see. If there's dust, if there's haze, anything, smoke like that, also report it. You can use the Globe Observer app or the Globe data entry tool. Now that is more for students and teachers. Now slide 22 goes into the satellites and the instruments aboard the satellite. And so we match your observations to the satellites called Aqua and Terra. One comes like around in the morning and one passes the equator in the afternoon. They both have the series instrument. So the satellite, think of it as the car, and the instruments, think of it as the people inside the car. And so a satellite could have multiple instruments. This series instrument, series stands for Clouds in the Earth's Radiant Energy System, is a way that researchers at NASA Langley study the effect of clouds in the climate and really trying to figure out how much of the sunlight is bouncing off of clouds. Is it bouncing off of the Earth's surface? Is it being radiated? How much moisture comes into account? All those things. Now, slide 23 talks about GEO. The geostationary satellites are much farther away. And so what we talked about, Aqua and Terra, are LEO, or lower Earth orbit satellites. So if you look at the graph on the left, there is a satellite really far away, and then there's a satellite close by that is taking pictures from west to east in the US. Aqua and Terra are LEO. So it takes them about 2 or 3 days to look at the complete Earth. If you look at the picture, the photo on the right bottom, and you notice that some of the globe has colors over it, that is the footprint of that instrument on board that satellite. So again, it takes about 2 days to look at the entire Earth. Now, GEO or geostationary satellites are much farther away. So if you look at the animation in the top right, you'll see the red dot being the satellite. And then as it turns, as the Earth rotates, the satellite moves in such a way around it that it's always looking at the same spot. So that's why geostationary satellites are mostly used for weather. If you go to slide 14, you'll see the different instruments or different geostationary satellites that we match to when you make an observation through Globe clouds. We have the GOES geostationary satellites that look at the US and North America. We also match to Meteosat, which looks at Europe and Africa. And then we have Himawari, which looks at Asia and Australia. So no matter where you're at, you can probably match to one of these. If you don't match, it might be in one of those times when there might not be data, or the data is still being downloaded. What I mean by that is that GOES data takes measurements every 15 minutes. Meteosat and Himawari take measurements every 30 minutes. And then we have to see if the spot where you're at has data or not. If you look at slide 25 now, once we gather all that data, which takes us about 1 day, so if you make observations today, you'll get your satellite match email probably tomorrow, and it'll look something like the part on the right, and then you'll have a link to the satellite that you matched. If you click on that link, you'll have a table like what you see here on the left. You'll see the date and time. Your observations are in green and towards the right. And then if you match to 1 or 2 or more satellites, it'll be in different colors. So in this example, geostationary is in yellow, and it was to gold. And then in orange is Terra. If you look at the bottom, there's all these little images. We send you the image that the satellite took. So if you were to click on where it says GOES 15 infrared, you would see what the satellite saw, and right in the middle of that picture is where you were at when you made your observation. And it's infrared data in this case. If we go to slide 26 now, again, it's just a reminder of all the videos that we're going to talk about. So again, this Thursday at noon will be geostationary data. But that week 1 satellite, you can go to the GLOBE program's YouTube page or go to the NASA Earth Facebook and look at those videos. And it'll show you how to read that satellite match table. On slide 27, another instrument that we match to is Calypso, which is, I think, my favorite satellite. So that photo of the volleyball team, that was one of 2 volleyball teams that I'm usually in at NASA, because my other volleyball team is the Calypso volleyball team. And I'll be forever loyal to Calypso, because I love that volleyball team. Calypso is a laser in space. There hasn't been anything so successful as Calypso. It's been up for about 15 years. And it kind of slices the atmosphere, kind of like cutting a cake. You can see all the layers. So the satellite match table is a little bit different. It's here on the right. So you can see where the clouds are at, and then if there's any aerosols. If we go to slide 28 now, you can see the footprint. Now, a laser, we use laser pointers when we're doing presentations because you can still see the laser even from far off. And that's the same from space. It's very accurate, but that means that not everybody can match to it. If you notice the image on the bottom right, those lines in reds and blues, that is the footprint of Calypso. Red means night and blue means day, or maybe I have them upside down. So if you click on that check satellite flyover portion on the app, you can see if you're one of the lucky ones that matches to Calypso or not. I have to usually drive like 15 minutes north of here where I'm at in Yorktown, Virginia, to get a satellite match. So if I'm in closer to Williamsburg, I get a satellite match. Or if I go towards, actually near ODU, I get another Calypso match. Now in slide 21, I'm start talking about the types of ways that we've used the data in research. One of the most important observations is total cloud cover and cloud type. And we want to make sure we're comparing your observations to citizen science to satellite data correctly. So these 2 beautiful faces are 2 interns we've had so far, and they have been juniors in high school when they've joined. Both Kevin and Olivia were just finishing their junior year, and we're going to be seniors starting in the fall, and they spent the summer with us making sure that our code was running correctly, that we were matching all the data that we could. And so when you turn 16 years old, you can be a NASA intern, and you can apply to any of the 10 different NASA centers and actually get paid. So if you're really good at computer science and coding, you are golden. Now, Kevin here, he taught himself how to program in Python. So you don't necessarily have to have taken classes or anything. As long as you are really good and know how to teach yourself, you're good. Olivia knew MATLAB, so if you know a program like that, C++, Python, MATLAB, you are good to go. Now, slide 30, we go into a little bit more of the details. And so on the left, that is Matthew Stark. He is an undergrad in atmospheric sciences. He is our intern again this summer. And what he's doing is working with the team at Goddard Space Flight Center and comparing the cloud observations made by people to model observations. So the GEOS or GEOS model is a model used around the world to predict clouds and cloud types and cloud cover, and to see how things will change in the climate. And when they're using your observations of clouds that you submitted through GLOBE to figure out how good has the model been at predicting that cloud cover. They haven't been able to find such a data set as GLOBE before, so they're really excited. On the right, there is an example of an obscuration. So that picture that's a dust storm. So don't necessarily think dust bowl as a dust storm. It can be a little, it can be a lot. I have colleagues in Alaska telling me that they're seeing a lot of dust storms from dry riverbeds. So as the climate is changing, there's new places that are seeing some sort of dust storms. So this would be an obscuration. So you would click on obscuration, click on dust, and then we recommend that you click on add pictures manually instead of the green giant button that says take pictures. And then you can take your photos of the horizon, which would be the best way to take a picture of an obscuration. Now with this, there's a picture there of a Boy Scout from Australia. The Boy Scouts have done a lot of work in Australia looking at dust storms and land cover, especially after the big fires that they had last year. We go on slide 31. If you live in an area that gets a lot of obscurations, it could be dust, it could be smoke, volcanic ash, things like that. This would be the step on how you would do it. And so obscuration means that something like that is blocking your view. Now, some people confuse obscuration with overcast. Now, overcast, what it means is just it's completely covered by clouds. So if you notice, those two pictures are completely different. If we go to slide 32 now, it's showing an example of a haboob. A haboob is a dust storm in Australia. And this was in October of last year. But if you notice, the blue dot is where this person was. There was no chance that we could have known there was a dust storm happening by looking at the satellite data because it was completely covered by clouds. It wasn't until he took the pictures, and we know that it's a he, because we thank him very much for these observations, that we noticed the dust layer within the photos. So again, your observations, even if we have satellites, are very important. In slide 33, it shows our Globe Clouds website on the GLOBE program. And if you go there, there is a dust portion where you can learn more, learn how the World Meteorological Organization, the WMO, is working with us because they're really trying to figure out where are the areas where dust is occurring. So not just in deserts. And then how often in photographs. They really want your photographs to see if they can model what's happening in the atmosphere based on what you observed. And slide 34 is all about contrails. So contrails is one of those types of observations that we humans do best. There's no instrument or anything that does it better than us. And we have middle schoolers making these contrail observations. So that's one of the schools, that's Montverde Academy in Florida, who have done over 1,000 observations of contrails, and they're comparing it to the airplane type that is causing it. And did you know that there's 3 different types of contrails? So when we ask you about contrails, we also ask you about the type, because the type is the most important thing. There's some that disappear pretty quickly, and those are short-lived. There's some that stay around, but stay very thinly. Those are persistent contrails, and some of them get thicker and kind of spread out. And those are the ones that can cause some differences in the Earth's energy budget. And those are persistent spreading contrails. And so even middle schoolers are contributing a lot. And I've sent their data to conferences like the American Geophysical Union and all these things like that. Now in slide 35, what I'm showing there is that we've made a clouds family guide, and this is also available in Spanish. So this is a guide for families that we've put together on how to make observations, but also how to do activities. And there's also video examples, and the video examples in the Spanish version are in Spanish. So I actually recorded with my girls, and we did it all in Spanish again, the activities. So you will probably have fun watching our videos. In slide 36, some of the ideas that we help out parents, especially, is how to do a science journal. As we are looking out the window, if we have to stay inside, or if we go in the backyard, what are some sentence starters or some questions that you can ask when you go outside? And you as an adult can help the little ones figure out what are they supposed to do. So looking at my sky, I notice. Or I wonder, in my sky, it looks like I notice that the clouds in my sky are. Those are ways that kind of guide them on how to make their observations. And you can see them or find all these in the family, the clouds family guide. If we go to slide 37, there are also some discussion questions that you can go through, like, what do you see when you look up? What are the shapes of the clouds? What does it remind you? So usually I ask these questions when I go into a classroom, and somehow maybe I go at a time that everybody's hungry, but I get like pancakes, cotton candy, cookies. I always get yummy, yummy stuff. So I'm excited to see if you guys come up with some food related descriptions as well. And so if we go to slide 38, I just want to say thank you to everybody for being here, even with these technical difficulties. It's really exciting for us to be with you and to learn more about you as well in your area, because without you, we would not be able to do this. So we hope to see you in the GLOBE program, either as a teacher or a professor. I have a lot of professors that use GLOBE in their science curriculum or courses, or through the GLOBE Observer app. Now, I'll be more than happy to answer any questions that you may have. Thank you, Rafael, for sharing my slides.
Okay, now at this point, please write the questions on the chat, and then we will pass it to Marilek.
Just a reminder, I cannot see the chat. So if somebody can read if there's any questions.
Read them to you, okay?
Okay, perfect.
Okay, Marilek, there is a question from Luis Angel Vergara Ortiz from Mexico. And the question is, thanks for a great presentation. Do you think that with cloud observation, we could predict or say something related to climate change?
Yes, the answer is yes. And so what we're noticing is that clouds are changing the cloud type. So this is where cloud type is important. And if you look at the chart, there's only two cloud types that precipitate or produce rain. So imagine if you stop seeing those two cloud types in your area, then you would not have a lot of rain happening. So yes, la contestación es sí, es muy importante para entender el clima, porque el tipo de nube predice lo que está ocurriendo con el cambio climático. Y hay dos tipos de nube que causan lluvia. Así que si no estás observando esos dos tipos de nube que están causando lluvia, va a cambiar el terreno en tu área.
Okay, here's another question. This is coming from Aaron John in Virginia. He asked, with the clouds observer, do you have to tell the type like cirrus cumulus or nimbus? Do we have to tell you that?
No, you don't. The one thing we do ask that it's required is total cloud cover. So how much of the sky that you see in all directions is covered by clouds?
Okay. Dory McLeod from Chesapeake, Virginia asked, does NASA control where the satellites go and observe? How many satellites are in outer space? And do satellites observe other planets? Thank you for sharing.
And that's a great question. So yes, there is kind of like a driver, if you will, a team that not necessarily has a joystick all the time, but there's these orbits, what we call orbits. Think of them as lanes in for cars, but this would be for satellites. And then we know where the satellite is at all times. Now, there might be other things out there. So there's a lot of stuff out in space floating around. And we mostly know where everything is. Now, sometimes we have to move. So if there's a satellite from another country and may have lost control, we move our satellite. Sometimes if there's solar storms, we have to turn it off. So that's a very specific team that does that. And there's a team for each satellite. Looking at the Earth, NASA has about 12 to 15 satellites that are just studying the Earth. But there's also satellites studying the sun and all the other planets. There's a geostationary satellite looking at Mars. So you could go and look at what's the weather right now on Mars, which is really, really fun. So not every planet has like a satellite, but we do use satellites to study other planets as well.
Are there any other questions? No more questions so far. Let's give them just a few minutes to see if they type.
No problem.
Okay, just 1 more minute for your questions. If not, we will conclude the session, okay? Amazing that you explained that everybody can actually help you from some other countries. And we will tell you later how many people from different countries came to your session. And we will be posting on the REYES website where we post all the materials, the different links that Marilek was sharing together with this presentation. Is that right, Marilek?
Yes, that's right.
Okay. Thank you very much, Marilek. Thanks, everybody. And sorry for the technical difficulties, but I think that we actually pull it off really good. And thanks again. Have a great afternoon. And I'll see you